Hi, I'm Sloan Young from Grayson County. I'm a mother of two, Jessica and Hunter Young. Jessica is 25. She's in her third year of medical school. Hunter is 21. I've been married to Kent for 30 years. We are in I'm in my 27th year of teaching. This is my third year as an MIT, and before that, I taught special education in fifth grade. I have a family picture there. That was from my daughter receiving her white coat, and our three dogs, Lucy, Bella, and Max. And now my friend Brandy will introduce herself.
I'm Brandy. I'm a mother of three. Isaac is 16, Braden is 11, Bree is 8. I've been married to my husband Brad for 11 years. This is my 12th year of teaching. My third year is in MIT, and before that I taught second grade for 8 years. These are some pictures of my family, and then my dog Buddy, and we have some goats on our farm that I didn't think I would like, but I really do.
Okay, and as always, the KCM website is a great resource. There's lots of professional learning and resources available for teachers, lots of virtual resources. So check it out if you haven't. Today, we'll be talking about the research to go along with place value. The standards, we'll be talking about the progression of addition and subtraction. We will be showing a video from Graham Fletcher. We'll discuss some inventive strategies and number talks, talk about how those are beneficial for students. We'll talk about activities from teaching student-centered mathematics, and then we will share out some resources for you.
So we decided to use some research that we found from the book Teaching Student-Centered Mathematics by Vanderwall. It says children are expected to develop, discuss, and use efficient, accurate, and generalizable methods to compute sums and differences of whole numbers in base 10 notation using their understanding of place value and properties of operations. Invented strategies generate procedural proficiency. We just thought this would be a good resource because a lot of people have it, and if they're like me, they don't have a lot of time to use it or to look at it, so we took the time to look at some of the things in there. The standards that we'll be covering today are fluently add and subtract from 100 using strategies based on place value, and add and subtract within 1,000 using concrete models or drawings using strategies based on place value.
Okay, so we're going to show this video, the progression of addition and subtraction. It's a video that's about 7 minutes long, so we're only going to show like a 2-minute clip of it. So when you get a chance, go back and watch the entire video. It's a great continuum to see. So Brandy, if you're ready to start the video.
So what happens in second grade? How does this build on what they've learned in first grade? Well, they might use two-digit numbers. And here is where we begin to introduce base 10 blocks because of that whole idea of unitizing that students are still developing in kindergarten and first. Again, just like before, we'll draw a representation for our model. We'll create another bundle of 10. And here's how students can begin to move from the concrete to the representation to the abstract. Now, it might not be efficient, or students might see that it's not efficient to write it out on the side all the time. So, to become more efficient, they can begin to use this understanding of partial sums and find a shortcut. 8 plus 3 is 11, 40 plus 30 is 70. And this understanding of partial sums, well, it leads brilliantly into their understanding that they begin to develop with partial products in fourth grade. So that works for addition, but does it work for subtraction? Well, we want to try and use models that continue to work the same and consistently throughout math. We don't want them to expire. So here we want to have 83, and we'll go back to that separating model. We want to put 29 inside there. Well, we need 6 more. So this is a really big understanding for students where they make that fair trade and that idea of unitizing. So now we can take the 6 from the 10 and we're left with 4. So how can we move again from the concrete to the representation to the abstract? Again, everything that we're doing here and all the work that we're doing, we're not undermining place value. And what's great is that this model, this understanding that we're building, well, it also applies.
Okay, so some of the points that I'd like to pull out in this video are, one thing he talked about was that kids don't get enough time to explore. So with giving kids time to explore, they begin to go from the concrete to the pictorial to the abstract when they have more time to explore and have a deeper understanding. Students are looking to use their most efficient strategies. They're using models that they can carry throughout their education and not just in one particular grade. He discusses fair trade, and he talks about how partial sums turn into partial products. So those are just a few of the points that I'd like to pull out from that video. But once again, the progression of this video is, I think it's great. So take the time to go back, click the link, and watch the entire video there. So the thing that we would like to talk about is how can we help students progress? One of the things that we talked about was, and he discussed in the video, is giving kids more time to explore, letting them have the opportunity to explore, letting students look for their most efficient strategy, learning to unitize, going from the concrete to the pictorial to the abstract. Okay, Brandy.
Okay, so one of the things that we found in the Van de Waal book was invented strategies. An invented strategy is any strategy other than the standard algorithm that does not involve the use of physical materials or counting by ones. Some benefits of invented strategies are that children make fewer errors, there's less reteaching required, children develop number sense, invented strategies are the basis for mental computation and estimation, flexible methods are often faster than the standard algorithms, and strategy invention is itself a significantly important process of doing mathematics. And some of the ways that we can help kids to come up with their invented strategies are number talks and just having kids to talk amongst themselves in the classroom and not just always the teacher doing all the talking. I know sometimes I tend to be I used to be the one that would just stand up there and talk for hours and then the kids wouldn't get to say anything, but I've learned through all these KCM trainings that that's not what we should do, that we should give the kids a chance to talk. So number talks and letting them work in groups to have that math discourse is always important. We just put some examples of our invented strategies on our presentation here. One of the ones that I think is really good is the HTO chart, which is the hundreds, tens, and ones chart. The kids can draw their numbers and they can represent their concrete models, and they can do that with or without the concrete models. It gives them a chance to show that they can bundle the ones and make a 10, or bundle the tens and make 100, or break them apart for subtraction. Also, the number line is one that we see quite often. The kids can use that forward or backward to add or subtract. And it really just depends on where they are as far as what they'll be able to use in their invented strategies. The more advanced they are, the more advanced their strategies become.
When the students use the invented strategies, they meet where they are conceptually, and it allows them to work where they are. Okay, so some of the activities that we have that go along with this. The first activity, or one of the activities that I would do, is I would lay out some arrow cards. And these are just arrow cards that we've ordered. We have in our attachment to this program, you have where you can make arrow cards. So I would ask the students to pick a green, a yellow, and a blue. And then I would ask them to order and read each number. So they would read 200, 40, and 6. And then we might talk about what place value those are. And I would have them to put them in order and build their number. And with those arrow cards, that's very easily done. So then I would ask them to take, after we've talked about bundles and sticks, made all of those, I would ask them to take and build that number on a place value map. And so you can see here that the number 246 has been built. And I noticed with my students, so a lot of times they would put 2 10s in the hundreds, because once we're going to the hundreds, they're not thinking, oh, I have to have 10 10s to make 100. So right there you can see visually that your students aren't grasping the concept of how much really is in the hundreds place value. So that's a real quick assessment that you can do, activity, and then you can extend on that. You can have them to add and subtract with the bundles and sticks, picking different numbers. The next activity that we're talking about is equal representation and showing how it can show a deeper understanding. So here we have 27 plus 16. So the student would represent 2 10s and 7 1s. And then they would represent 1 10 and 6 1s. And showing that 3 10s and 13 1s, also being able to show that would be 4 10s and 3 1s. So they have that deeper understanding of making that equal representation and making that connection. And then you can take that on to different multiple representations of how they could represent the number 57 and 241. Brandy, do you want me to go ahead with those, or do you want?
I can do that. So you can represent, if a child can represent a number in multiple ways, that means they really have a deep understanding of place value. 57 could be represented as 5 10s and 7 1s, or 4 10s and 17 1s, 3 10s and 27 1s, and all the way down to just 57 1s. You can do the same thing for hundreds. 241 could be represented as 2 hundreds, 4 10s, and 1 1. Or it could be 0 hundreds, 24 10s, and 1 1. There's just lots of different things that you can do with those numbers. And if a student can give you multiple representations, they have a deep understanding of place value, because they know what the hundreds place means and what the place means and the ones are, and they can manipulate those numbers into any of those things.
Okay, so the next activity that we have to discuss place value would be which one doesn't belong, why, and depends your answer. So you can look at these 4 numbers, and you may say, well, 53 doesn't belong because it's not in the hundreds, or it doesn't have 100. So another student may say, well, 137 doesn't belong because it doesn't have a 5. Another student may say that 529 doesn't belong because it's more than 500. So when you start looking at numbers like this, like 53 and 529, some students who don't understand place value are going to think that those numbers are very close together. So here you can just do a little defend your answer type thing and really see if students have that conceptual understanding of place value. The next activity that we have to show you is it's a card activity, and for this card activity, I would only use ACEs through 9, and I would lay out 6 cards, and I would have the students to make the largest number that they could with picking 3 of the 6 cards. So here, 877 would be their largest number. So then you could take that and you could have the students to make the smallest number using the only 3 cards. Then you could extend that, having them to add or subtract, going on with your place value here. Yesterday, when we actually did this live, we had some who people gave suggestions on other things that we could do. You could have the students to make the second largest number that they could, after you've taken 877, well, what would be the next number under that, like the one smaller. There's just a lot of different things that you can do with a deck of cards, and I have actually done this in a 3rd grade classroom in centers. The kids love it. They like to have one that can pull out that number, or the largest number, the smallest number, and then they kind of like to figure out other activities that they can do with it. So you can do more than 3 cards or 6 cards. I just did that for the purpose of this, so you could lay out 9 cards, have them to build a 3-digit number. There's just a lot of different activities you could do with that.
You could also do it with smaller numbers. You could lay out 4 cards and make the
2-digit numbers. Okay, so as always, the KCM website is available for you. Our email is attached. If you have questions, feel free to email either one of us. We would be glad to respond to you, or if you have questions about anything that you see in our presentation, or if you have suggestions for us, we'd like to hear those also.